Here's an example in which we have a weight suspended from two ropes coming down. The two ropes hold the crate as shown. The tension in one is 598 newtons. Those are called newtons. That's a force unit, a metric force unit, in a direction 20 degrees with the horizontal. The other is 795.45. So the question is, how much does the crate weigh? Well, basically the whole deal is this is a vector problem, and you need to look at this right here. This is a vector that's pulling up to the, did kind of a funny thing there, up to the right, and this other one over here is a vector that's pulling up to the left. So we got those two vectors, and together, and then the crate itself is got weight pulling straight down. So those three vectors must be balanced because the crate is not moving. The three vectors must add up to equal 0 because the crate is not moving. Does that make sense? If the forces were unequal, then the crate would be moving. That's what makes things move, right? If you push on something and there's an equal force pushing on the other side, then the crate doesn't move. But if the forces are unequal, if this one's a bigger force, then the crate will move that way, won't it? So if the crate is not moving, we know that the forces must be balanced. They must add up to equal 0. The crate's just hanging there. So we know, therefore, that the forces must balance. They must add up to equal 0. That's what that means. Okay. Specifically, that means the X, let's call this rope 1, and this is rope 2. So the X for rope 1 plus the X for rope 2 must equal 0. And the Y, and there's no X for the crate. The crate just pulls straight down, right? The Y for rope 1 plus the Y for rope 2 plus the Y for the crate must add up to be 0. There is no X value for the crate. The crate's just going straight down. He has a Y but not an X, right? That's what must be the case. So, in particular, we're going to use this equation to find the Y value of the crate, which is the weight of the crate, how much the crate pulls down. So we just need to find the Y value for rope 1 and the Y value for rope 2, and then we can solve that equation for the Y value for the crate. So that's the game plan. So first off, step 1, so here's step 1, I guess that was the plan. We'll call that step 1. Step 2, write rope 1 and rope 2 and the crate vectors. Okay, so what I'm going to do is I'm going to put an axis system. I think that'll make it easiest for us. Right there where they all connect. Okay, and so we have, let's go with rope 1. Rope 1. Now, what's rope 1's angle? This is his angle from, remember, angles are always measured from 0 degrees. What's that got to be? Well, if this one's 20 here, then this one here's got to be 20 also. Why so? Well, because those are both from the horizontal. See how this is from the horizontal to the rope? So from the horizontal to the rope, these have got to be the same. They got to both be the same angle. In geometry, those are called alternate interior angles. Basically, if you have two parallel lines like these two, these are parallel, they're both horizontal, cut by a transversal, something goes between two parallel lines. The Z, I call them Z angles back when I used to teach geometry. See how these two angles here make like a Z? See how that's a backwards Z, like the mark of Zorro or something? The two Z angles are equal. They're called alternate interior. They're on alternate sides of the rope, and they're both interior angles. So those two angles have to be the same because they're both the same rope coming from the horizontal. So that's got to be 20. Likewise, if this is 45, this one here's got to be 45 also, because those two are the same. They're both coming from the horizontal to the rope on the other side, right? Okay, great. So what's the orange angle? It's got to be 160 degrees. Do you see that? From here all the way to there has got to be 160 because it's 20 the rest of the way to make 180. See how I got that? And remember, we need, let me write, angles must be from 0 degrees counterclockwise, because that's how we measure actual angles. So for rope 1 then, rope 1 is, remember how it works? You take the magnitude, that's for the x and the y. It's always going to be magnitude cosine theta for the x. I'll just call it the x. And the y is magnitude sine theta. That's on the formula sheets. So therefore the x is magnitude for rope 1. This is rope 1 right now. It's 598. That's the magnitude. In this case, it's the strength, the tension that's in rope 1. 598 cosine of the angle 160. That's the angle theta. And y is 598 sine of 160 degrees. Again, the angle must be from 0 degrees counterclockwise. So we don't use the 20, we use the 160 for rope 1. And then for rope 2, going to kind of run out of room here, aren't I? So for rope 2, the x is going to be m cos theta. So for rope 2, that's going to be, what's rope 2? 795. 795 cosine of 45 degrees. And y is 795 sine of 45 degrees. All right, so we have the x and the y for rope 1 and rope 2. All right, so what do we know then? We know that step 2, we wrote the R1 and R2 and create vector. Well, the create vector is just straight down y component. So now step 3 over here, I'm going to wrap up this problem, step 3, using this formula right here. Y for R1 plus y for R2 plus the y for the crate must equal 0. Right? Because right at this point, all the y values must cancel out. If not, that crate would be moving up or down. However much rope 1 is pulling up and rope 2 is pulling up, the crate must be pulling down the total amount that rope 1 and rope 2 are pulling up. Right? Rope 2 pulls to the right and up. Rope 1 pulls to the left and up. So they both pull up, and crate pulls straight down. So the amount over here that rope 1 pulls up and the amount over here that rope 2 pulls up must equal the amount the crate pulls down. They must add up, in other words, to be 0. These are both going to be positive, and this guy is going to be a negative amount. So what we're going to say then is that the amount y for rope 1, which is what? Right here. So that's 598 sine of 160 degrees plus the y for rope 2, 795 sine of 45 degrees must, well, in fact, actually, how about I just solve for the crate here? Is that okay? I'm just going to basically jump these guys to the other side. We're going to have y for the crate is going to be a negative y rope 1 minus y for rope 2. They're just going to end up negative on the other side. When I basically subtract y rope 1 and y rope 2 to both sides. Minus y rope 1 minus y rope 2. They cancel out here. I get the crate alone, so the crate alone will equal negative the y for rope 1, which is right here. The y for rope 1 is 598 sine 160 degrees minus, we have room here, minus 795. I'm running out of room terribly. Minus 795 sine 45. So hit the buttons on your calculator. I'm going to do it. 598 sine. Make sure you're in degree mode. These are degree angles, obviously. I'm getting minus 766.6779. I don't know how many places they want us to round, but there it is. That's how much. Now, why is it negative? Well, because the crate is pulling down, but they don't want you to give, I hope this isn't confusing for you, they don't want you to give a negative answer. In the end, they want you to just say the amount of weight. You know, so that'd be like if I'm pulling downwards, it's just a convention, right? Negatives and positives are just made up, right? The world, the universe in which we live in, does not know down is negative, up is positive. What is down and up? The world's spinning, right? So it's just conventions. They don't want a negative answer. We know the negative means the crate is pulling downwards and the ropes are pulling upwards, but they just want the straight answer, 766.6779. So that's how we did that. We just found rope 2 and rope 1 vectors. Remember that you have to use the angles from 0 degrees. So it was 45 degrees, same as that one for rope 2. This was 20, same as that one for rope 1, which meant it was 160 from 0. You've got to use the 160 from 0. Whenever you do vectors, you have to use the angle from the positive x-axis counterclockwise. So that's 160. So 160. And so, therefore, that's a 20-degree angle here. So we did the x and the y. X is m cos theta, y is m sine theta, m is the magnitude. Found the x and the y for the two rope vectors, and we solved this little equation. The y values for the rope vectors must add up with the y value from the crate vector to be 0. Solved for the y value from the crate vector and came out negative, but they don't want the negative answer.